Hello, Maurits here, and let's us have a look at the normal distribution yet another time, particularly about the standard normal distribution. But we should start to look at ordinary problem and then turn that backwards, so to speak. Say we have a normal distribution. Say we have an average 100 and a standard deviation of 10, so variance of 10 square or 100. So our average is 100 and our standard deviation is 10. And suppose we are to find what is the probability that this variable x has the value above 107, say. So this could, for example, be some product that is made that is 100 grams and with a standard deviation of 10 grams. What is the probability that we will buy something that is more than 107 grams? So we go to stat, distribution, normal distribution, cumulative. In the lower value, it's from this value, so you write 107. In the upper, we write something very big. Since we want to go above this, our standard deviation was 10. Our average is 100. And we calculate and find that the probability is about 24.2%. And then we want to do another calculation, say the probability that x is less than, say, 91 grams. So we go back here, we change now our lower bound to be something very, very far to the negative side, so to speak. So I write minus 9x 99. So if you look at the graph of this, we want to be very much far away in that end. Remember now that we have an average 100. Our standard deviation is so that we have 110 grams there and about 90 grams over there. So say we want to calculate this probability. Our upper value now will be 91. So from basically minus infinity to 91, we have still 10 and 100. We find the probability to be about 18.4%. We have solved the problem. But suppose we were given this down here. So this is information we are given. Say that they say in the text they could say that we have this random variable where x, the probability that x is larger than 107 is 24.2, and the probability that x is less than 91 is 18.4. Find the average and the standard deviation. How could we find these? And the problem is that we can't use our ordinary calculations over here, the inverse calculation. We can't use this directly since we don't know these values. And now comes the standard normal distribution. And as we saw in the last video, we can turn an ordinary normal distribution to a standard normal distribution by taking our x values minus our average and divide by the standard deviation. And we usually write that as z. So this first thing here, the probability that x is larger than 107 equals to 24.2% should be turned to something with z instead. And we have an x value here, that's this. So what I will do is instead write that the probability that z, so the standard normal distribution, is larger than, and what is the x value? It's 107, so I write 107 minus the average that we don't know divided by the standard deviation that we don't know equals to 24.2%. But now we can actually use the calculation here, since we, in the standard normal distribution, the average is 0 and the standard deviation is 1. So I go in here and I will start with, since 107 is to that direction, right, 107 or more. So I will go in here and say I want to have a right tail. The area, remember the area is the probability, is 0.242. Our standard deviation now in the standard normal distribution is 1, and our average is 0. And we calculate this, and what we have found now is this value here, because that is the x value, which now is the z value. We found that that was about 0.700. In other words, our x value, that is 0.700, must be equal to 107 minus mu over sigma. So 2 unknowns, 1 equation, we need another one. So take our second equation, the probability that x is less than 91 equals to 18.4%. We want to turn that to standard normal distribution again. So we do the same thing there and say, okay, the probability that z is less than something, what would that be? The x value is 91 minus the mu that we don't know, minus the sigma that we don't know. So the average and the standard deviation, and that should be 18.4. And now the same thing, we can use the inverse function to find this part here. So we go in to the calculator. We now have the probability in that direction, right? So we have a left tail, and the probability was 0.184. Remember again, the area is the probability. We still have the standard normal distribution, so this will be 1 and 0. And we find this value to be minus 0.900. In other words, minus 9.00 equals to 91 minus mu over sigma. So how can we use these two facts? We can combine these now. We take the first one, and I would multiply here up the sigma. So I get 0.77 sigma equals to 107 minus mu. I take the second equation. I would multiply the sigma up again. So minus, 0.900 there. So we get 0.900 sigma equals to 91 minus mu. So we have a system of equations. And to get rid of the mu, for example, I could take one of the equations minus the other. So I will take the upper equation minus the lower one. So that will give us 0.700 sigma minus, since we take the top one minus the lower one, 0.900 sigma equals to 107 minus 91. And the mu's will disappear. So what will this be? That would be 0.7 minus, that would be plus 0.9 sigmas. And 107 minus 91. That is equal to 16 here, right? And 0.7 plus 0.9 is 1.6. So we get 1.6 sigma equals to 16 divided through by 1.6. Sigma equals to 16 over 1.6. That is equal to, oh, that's the sigma we started with. So we were able to retrieve our sigma back again. And then we also need to find our average, our mu. So we can take one of these two equations. Say I take this one. So 0.700 times our sigma, that was 10, should be equal to 107 minus mu. Okay, so that will give us 7 equals to 107 minus mu. I could add mu on both sides, and I will also subtract 7 from both sides. That will give us mu equals to 107 minus 7, or equal to 100. And that is what we started with. So in other words, we can work in both directions. First, we made this exercise by finding these two probabilities. Then we pretend we don't know this. So in an exam, they could ask about, given these two, find these two values. And the way we found that by using this standard normal distribution. So remember, this is an x value, so we can use that value for x in this one. That's what I did. And then we use the inverse function to find the value here. As we use the function in one direction, from this to find that, the inverse function from this will find that. So, I hope this helped a bit. Thank you.